Welcome to this video on revision worksheet 13. So this worksheet had a series of questions that came from older mock papers, so it was quite a mix, so I haven't specified exactly where, because a lot of these were pre-project maths questions, which I suppose just to take them and take a look at it, so they're not really in the project maths style, but they do provide some really good little pieces of work and show us, especially there's a little bit here with thirds, and I think our division as well. So they're just good questions. So let's work through them now. So question 1, solve the equation x plus 1 over x is equal to 10 over 3, where x is an element of the real numbers but is excluded from 0. And the reason that we see that exclusion of 0 is because we have 1 over x. So we know if that was 1 over 0, that would not exist. We can't divide by a 0. So all that's telling us there, it's just saying it can't be 0, and we should know that already. Now questions like this, you need to really focus on what we have here. So we have an x to a power of 1 and we have a 1 over x. And what that 1 over x means is the power of minus 1. Now, what we would generally do in these questions and how we're going to approach it is we're going to get rid of the fractions. And the reason that we're going to get rid of the fractions is so we can create an equation that we know and we are familiar with, which will be a quadratic, and we'll work with it. But we have to be careful when we create a quadratic rather than when we start with a quadratic. So to create our quadratic, we're going to find the lowest common denominator. The lowest common denominator of 1x and 3 is going to be 3x. So we're going to multiply the whole way across by 3x. So let's start with what we have already. 1 over x equals 10 over 3. So we're going to multiply each piece here by 3x, this piece here by 3x, and this piece here by 3x. So the 3's here cancel, that x cancels, and we're left with 3x squared plus 3 is equal to 10x. Bringing that across, we get 3x squared minus 10x plus 3 equals 0. Now, notice how we've got our quadratic and we can solve that either using our guide number method, just straight into factorization, or we can use our minus b formula. So let's solve that here now. So if we want to use our guide number method, our guide number is plus 9. Plus means the signs are going to have to be the same. So we get a minus 9 and a minus 1, which will give us our minus 10x. So we get minus 9x minus 1x plus 3 equals 0. Take out a 3x that's common, we get x minus 3. We take out a minus 1 and we get x minus 3. And we're left with 3x minus 1, x minus 3 equals 0. Solving that, we get 3x minus 1 equals 0, so x equals a third. Here we get x minus 3 equals 0, so x equals 3. And there are answers. However, you have to be very careful, and like I said at the start, we didn't actually have a quadratic to begin with. So we may find that although we get two answers, both answers may not actually be valid. And that's really, really important for us because we see something similar when we do our third equations. We don't have a quadratic to begin with, we create the quadratic. When we create the quadratic, we have to always think, are both answers valid? So what we have to do in this case, because we didn't start with the quadratic, is we actually need to check and see, are both answers valid? So the first one we're going to check is x equals a third. So we're just going to take our original equation and we're going to sub in a third plus 1 over a third is equal to 10 over 3. So what we end up with is a third plus 3 is equal to 10 over 3. And what that is, it's a third plus 9 over 3 is equal to 10 over 3. So we get 10 over 3 equals 10 over 3. And we say that this is valid. So our first answer there, a third, is valid. So the second one we want to check is x equals to 3. So we get 3 plus third equals 3. Sorry, equals 10 over 3. So we get 9 over 3 plus 1 over 3 is equal to 10 over 3. So 10 over 3 equals 10 over 3. So both of our answers here are valid. So question 2. Root 2 minus 1 is a root of x squared plus bx plus c is equal to 0, where b and c are elements of z, which is telling us they're integers, so they're positive or negative whole numbers. Find the value of b and the value of c, and hence find the other root. Okay, so we know that this is a root, so as soon as you're told a root, we should always write in the same form. X equals root 2 minus 1. Now, we're not used to seeing roots in this form. Generally, we see roots presented to us as integers and we work from there. So presenting here this irrational roots, that root 2, that is slightly different to anything we've seen, but we're still going to treat it the same way. So if we are told something is a root, we know that we can sub it in and it should work. So we get root 2 minus 1 squared plus b times root 2 minus 1 plus c equals 0. So multiplying this out, so this works out, so you can square the first, which gives us 2, twice the first by second, so minus 2 root 2, square the last plus 1, so square is exactly like we'd square our algebra brackets. So we get plus b times root 2 minus b plus c equals 0. So once we've done our substitution and we get this line here, we can clean it up slightly, but not a lot. So for example, we have here a 2 and a 1. That's pretty much all we can have. So we have 3 minus 2 root 2 plus b root 2 minus b plus c equals 0. So that's as clean as we can get it, or it's as simplified as we can get it. And at this point, I suppose we can note that we get two unknown coefficients. So we have a b and a c, but we've only one equation. So we're going to have to solve this in a slightly different way than a normal linear equation. So if you take a look here, we have two different types of numbers in our equation. We have what will be considered our irrational numbers, so anything with a square root. And there's two of those. I'm going to highlight them now. So we have this number here, which is irrational, and this number here, which is irrational. And then we have rational numbers. So these are ones that can be written as a fraction. So we have the 3, that's rational, minus b is rational, and plus c is rational. So if we take a look at that, now having it highlighted, it might be slightly, or it might be clearer to you that we have a minus 2 root 2 plus a b root 2. And that's on the left hand side. However, on the right hand side we have a 0. It all equals 0. So effectively those irrational numbers are going to have to cancel each other out. What that means for us is we can do something similar to what we do with our algebraic identities or our unknown coefficients, where we say that the x squared terms on one side equals the x squared terms on the other, and the x terms on one side equal the x terms on the other. So here we can say, well, the irrational terms, so let's start with the irrational. So the irrational terms must be equal. So on that side we have a minus 2 root 2, a plus b root 2, and that all equals 0 because there's no irrational numbers on the right hand side. Working that through, we can get rid of the root 2's and we're left with b equals 2. So we can do the same thing for the rational numbers. We can say that 3 minus b plus c must equal 0. We already know b is 2, so we can slot that in. So we get 1 plus c is equal to 0, so I get c is equal to minus 1. So our new equation, or our updated equation, is x squared plus 2x minus 1 equals 0. Now, there is a follow-on piece of that question, so do make sure that you're doing all parts of questions that are asked, and that is, hence find the other root. At this point here, we have the quadratic, so we can very easily go along and use the minus b formula. We won't be able to factorize this. We can use the minus b formula where a is equal to 1, b is equal to 2, and c is equal to minus 1, and work through. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And when you work that through, you're going to get two answers. You're going to get minus 1 plus root 2, and x equals minus 1 minus root 2. Now, there is no issue doing that at all. It doesn't take that long to do the minus b, and hopefully you're not making any mistakes while using it so much. There is, however, a slightly different way you could approach that. And that is by looking at the initial root that you've been given. So the root is x is equal to root 2 minus 1. That's what we were given in the question. Because there's a square root in it, we can make a guess that actually that's something that looks like it's come from the minus b. However, we would usually write it the other way around. Minus 1, the whole number first, plus the square root. If that was one of those, if that was one of the roots that we got from minus b, then the second root must be minus 1 minus root 2. These are the conjugates of each other, and you'll see this logic a lot more when we move into looking at complex numbers. There is absolutely no problem, like I said, using the minus b formula and working through what we have, but just if you can see that little shortcut there at the start, it might save you a few minutes. So question 3. X minus 3 is a factor of both of these equations, and that's important because they've given two equations here. It's 3 parts to this question, and they'll come back to that first statement. At this point, you need to really be able to look at a question and identify, well, underneath where it says question 3, it's given me a statement. This statement must be true for the whole question. Sometimes people get confused about what is linked to the question and what isn't, what's part A and what's part B and all this. So this is not split into part A or part B. This is just telling us a statement, and this statement must be true for the whole of question 3. So it said find a value of A. So we have a factor. So if our factor here is x minus 3, by that logic we also know a root. So the root then is x equals 3. So we know that when we have a root, it will sub in and it will work. Now, I'm going to use this equation here because it just has an a in it, while the other equation has an a and a b, so that's not going to be as useful for us. So we have 3 cubed plus 3 squared minus 3a by 3 minus 3a equals 0. This gives us 27 plus 9 minus 9a minus 3a equals 0. Cleaning that up, we get 36 minus 12a equals 0. 12a equals 36. A equals 3. Now, you can of course use the idea of the factor here, and that means you could show that x minus 3 divides in and it will leave us with no remainder. However, I think using the idea of the root is just a little bit easier. Some people don't mind long division, and that's fine, but generally working with the roots, if possible, is always going to be our slightly easier option. But you can of course use the idea of division. The second part of this question then says find the roots of these equations. Of the equation x cubed plus x squared minus 3x minus 3a equals 0. Now, we know that this equation can be updated to be x cubed plus x squared minus 3 times 3, so minus 9x minus 9 equals 0. So if I want to work out the roots, I already know one root. So root 1, so we know x is equal to 3, because we knew that x minus 3 was given as a factor. So we know that x minus 3 is a factor, so if we divide x minus 3 in here, we'll be left with a quadratic, which we will be able to solve for the other two roots. So this goes in x squared times. So we get x cubed minus 3x squared. So then we subtract here. This turns to a plus. And we're left with 4x squared. So this goes in 4x times. So we get 4x squared. Bring down our minus 9x. Here we get minus 12x. We subtract, so this becomes a minus, this becomes a plus, and we're left here with 3x, and we bring down our minus 9, this gives us a plus 3, so we get 3x minus 9, and that leaves us with no remainder, as we would expect. So we now have a quadratic x squared plus 4x plus 3, and we want to solve this. So you can use your guide number here, that's absolutely fine. And when you do, you'll end up with x plus 3x plus 1 is your brackets, and you'll get x is equal to minus 3 and x is equal to minus 1. So the roots, we have 3, so we have root 1, which was x equals 3, that was the one we were given in the form of a factor. We have x equals minus 3, and we have x equals minus 1. Do make sure that you're showing all of your answers here, even the one that you've been given. Depending on the question, if it's not clear, you could lose a mark or two. So it is important that you display all your answers together. So the last part of this question says, find the range of values of b for which all the roots of the equation are real. So we don't know what b is. We're not even going to be able to work out b. You can try. We know what a is, and we know that x minus 3 is a factor, so x equals 3 is a root, so we can sub in 3. But when you do that, you'll notice everything cancels and we don't actually get anywhere. So what we're going to do instead, we're going to take this and we're going to sub in our a, which we know, plus bx minus 3b, and we're going to leave it in terms of b. Now, the question has asked us find the range of values of b, so they want us to work out not just one answer for b, but a range of values. So it makes sense that when we try to find a solution or an answer for b, we're not going to be able to get it. So what we do know about this is x minus 3, is a factor. So we know the factor x minus 3. I've already said that x equals 3 is not going to help us. If you want to try it, if you don't believe me, that's fine too, and you'll see that actually it doesn't give us anything, it just everything cancels. So if the root doesn't work, we're going to have to use the factor. So we know that when we divide x minus 3 into this, it's going to give us, it's going to divide in evenly, so it's going to give us no remainder. It's 3x squared plus bx minus 3b equals 0. Sorry, I'll get rid of that equals 0, don't need it. So it goes in x squared times, so we get x cubed minus 3x squared. Now, when we go to subtract this, notice that both pieces cancel. It's unusual, but it's okay. But what we do need to do then to move on is we need to bring down both pieces here. So the next thing we have is x divides into bx, and that goes plus b times. Gives me bx minus 3b, and the same thing happens. We get nice cancelling. Okay, so that has divided in evenly, and we now have two factors. So we now have x minus 3 is one factor, and we have x squared plus b is the second factor. The question asks us to find the range of values for which range of values of b for which all the roots are real. So here, x equals 3, this is a real root. So we have one real root, that's fine. Now we want to say, well, what about this? We want this to have two real roots. Now, when I say that, in your head, there should be a little alarm going saying, oh, two real roots. I know something about that. And we do. We have a quadratic. Okay, it's not a quadratic trinomial, but it is a quadratic. And that's x squared plus b. And we can use the discriminant. So just a reminder, the discriminant, it's the part of the minus b formula, b squared minus 4ac. It's a bit under the square root. And we know when that's greater than or equal to 0, we have real roots. So working with this quadratic, a is 1, b is 0, notice there's no x term, and c is actually b. So we end up with 0 squared minus 4, 1 times b, greater than or equal to 0. So minus 4b is greater than or equal to 0. So 4b is less than or equal to 0. Remember our rules of inequalities. Change the sign. You have to also change the inequality. Okay. Inequality. So we're left with b is less than or equal to 0. So therefore, when b is less than or equal to 0, the roots of the equation will all be real. And that's important. They'll all be real. So the idea of using the discriminant. So here we have to work with the idea of, if we want to figure out if a cubic has real roots, or it might have one real root or two real roots, whatever way we want to work it, we know the first one, and generally our first root will always be the integer root that we've been given. It will be the real root, and then we have to work with the quadratic when we divide that first factor in.